Well, now we see why we need an AI lab for protecting AI. Next speaker is Dr. Amit Somech. He's a senior lecturer at Computer Science Department, Bar-Ilan University, and a research scientist in Sygnia. Please feel free to expand.
Thank you, Oren. I will expand, and I have a dedicated slide for that. Where is me? Thank you. Great. Okay, so I will present myself, but in a little bit. So this talk is about how we auto-generate explainable data-driven insights in cyber investigations. Don't freak out, it's going to be no formulas today. Right, so this is a joint work. I'm at Bar-Ilan University and also a research scientist in Sygnia. Let me take you today into the world of cyber investigations. So cyber investigations are difficult, right? It's literally and figuratively finding a needle in a haystack, right? Because as an analyst, you need to query over a massive amount of unstructured, messy data, and you need to spend hours of doing manual work, such as searching for something vague, something suspicious that may imply eventually on a cyber attack or a security threat, right? And not only that you need to investigate, invest time in this, you also need to have extensive knowledge, experience, and domain expertise in order to be good at this job. So, Zeitgeist, can ChatGPT do it? Well, there are reasons to believe that it can, right? Because LLMs are trained over millions or billions of documents, including cybersecurity ones, right? Communicating with such models is simple and does not require knowing SQL or any programming. More importantly, answers are provided immediately. As an analyst, you sometimes run a query and it takes hours to complete. But there is a hunch, right? There is a trust issue here. So it's a great technology, but it's really good for generating pictures and stuff, but would you trust it with your health or more importantly, your network and data? And this hunch is actually backed by facts, right? At least in the concept of cyber security, right? Because LLMs are indeed trained on billions of text, but they're mostly human-generated text, while most cyber data is machine-generated, non-textual, and often is not publicly available for training such models, right? And also the input and output are very limited, right? So you can ask questions about, I don't know, a certain kilobytes of data and ask it to reason about it, right? But in cyber data, the data can accumulate to terabytes, right? And you cannot feed that to a large language model yet, right? And very importantly, LLMs hallucinate, right? So they basically lie to your face. How would you feel if an analyst that works for you very confidently tells a lie? Right. And in order to convince you that I'm not hallucinating, let me present my personal timeline about myself. So I began my way as in the cyber operations business in the Israeli Defense Forces intelligence section, doing stuff. At night, I pursued my master's degree in computer science, doing database systems and machine learning. And then after a well-deserved break, I crossed to the other side and became a cyber analyst, where I did many incident response investigations, and I literally did this stuff. I continued in academia and pursued a PhD. I wanted to do it on the same fields, right? Machine learning and data. But as I kept doing more and more incident response cases, it blew my mind how frustrating and difficult it is. And more importantly, how alone I am in this, right? So there is no tool to help me, there is no software to help me reason over this large amount of data and reach insights in a reasonable time. So I decided to make this a research problem and went into the field of AI-driven data analysis. Several years later, I continued to do this in Sygnia, and I'm now working on advanced analytic solutions. And I became also a faculty member at the computer science department in Bar-Ilan University, where I'm heading the analysis bots research group, right? So this is a little bit about me and why am I probably not hallucinating, hopefully. Okay, so back to our field, right? So what's AI-driven data analytics? So it's not exactly like ChatGPT, but the main problem here is that the main question that we ask is, can we hook machines or algorithms to our data set and allow them to perform the queries, right? So it's like a machine that plays chess. It can play many, many chess games and then learn how to do it. So in the same way, machines can make much more queries per minute than human analysts. Also, machine can quickly reason and analyze other queries, whether they made by other analysts or machines. So this is the concept. And what's our ultimate goal here? Is building this robot analyst that will replace human analysts by taking them out of the loop and extract insights all by themselves. So not yet. And we work on sub-tasks which are more realistic, like assisting users in coming up or conceiving analytical steps, suggesting analytical path to interesting data segments, help users discover insights and reduce what we call the time to insights and provide exploration ideas over the data. And we also make automatic explanations where we help users understand the results of their analytical queries and help them to build a story from the data. Really quick examples for such systems. So this is a recommender system that we developed. So it works basically like how Netflix is recommending movies and TV series to you by mining what other similar users have watched to you. And so this is basically the same thing, but in the concept of data analysis. So we see what the current user, what analytical queries did they make so far, and on which data set, and we recommend what other people might have done in such situations. Another system that we worked on is a system for visual explanations of analytical operations. So here the user performs a very difficult, not a very difficult, but a query that results in thousands of rows, right? So it's very difficult to then look at the results and understand why is it interesting. So in the background, we mine many, many reasons for the query to be interesting using causal inference. And finally, we choose the top K one and present them to the user in a really nice, coherent way. So these are three reasons that the query is interesting and what's in it. So, and it's already on GitHub. Take a picture. So can we use this in cyber investigation? Not quite. So here is an example scenario of a ransomware attack. Don't worry, it's deliberately small, so you cannot read it. So it's very complex. It describes a phishing email that then send the user to an exploit server, and then a malware is installed, and it tries to propagate, and then contact a CNC server, etc. Right. So what I'm trying to say is that attacks are often complex and contain multiple steps. Right, and the evidence for them is hidden in multiple log sources that contain millions of daily events. So it's really difficult to catch that. And the investigation revolves around finding, as we said earlier, vague, suspicious, or anomalous behavior that may be connected to the attack. Right, so it's not simple, straightforward SQL queries that can solve this matter. And this is a major problem for AI-driven analytical tools. So what we suggest here? We suggest just to extract and publish better data. So the raw logs are difficult to work with, both for AI tools and for humans. And we need better, high-quality additional layers. So we'll cover 3 layers today. The first layer is tracking entities, right? So entities like users and hosts can appear in different forms across different logs, and you want to track them and pinpoint them and put them in the same place. The second layer is tracking their behavior, so their routines over time. So how do they behave, what they usually do, and we record that and use that. And the third layer is where we capture and measure anomalies in the data. So we check when an entity deviates from its behavior and do something weird. All right, so let me quickly cover these layers. So the same user or host can appear differently in every log source, right? So this is me in different sources. So this is my Microsoft sign-in, my VPN, and my event log 4624 usernames, right? So they are similar but not identical, right? So ideally, we want them all to be connected to the same entity, right? So this is my entity ID. And if we are already there, then it would be useful to also track stuff that properties that I had at the time, right? So like my browser, my operating system, my IP, and things that are relevant for my entity, right? And if we do this, okay, if we save this properly, we can quickly fetch answers to questions such as how frequently is a certain IP address used in an organization, and quickly get an answer. Like this IP address was used this and that times by these users, and the evidence come from all of these logs here, right? And this is possible because the data is ordered and organized better. Okay. Behavioral patterns. So a pattern is how an entity behaves like over time, recurrently. So an example pattern to be what would be a user's working hours. When does she logs to her computer and doing the actual work? So this pattern can be extracted from many log sources such as 4624. The entity is in a field called account name, and the weekday and hour are extracted from the timestamp. And this lets us generate this very nice heat map that show what's the usual working hours of an entity. And when we capture such patterns, relevant patterns, we can also fetch answers like which hosts regularly transmit more than 1 gig a day, and get the answer quickly, right? And the last layer is the anomalous activity layer. The challenge here, the research challenges, is the fact that in a modern network, everything is weird, everything is an anomaly, nothing stays the same, right? So what we need to do is to tell how weird is this and how weird is that. So we have 2 scoring mechanisms, which I'll not go into because of time. Right, so basically we check how weird something with respect to an individual entity and also with respect to other entities in the same organization. And by doing so, we can again answer questions like what's irregular processes were extracted on some laptop on a certain date and get a timeline only of relevant items. Right, okay, so what I'm trying to say, and the main takeaway here is when the relevant data is easily queryable and organized well, even ChatGPT can do it, right? Because then the problem is not to ask ChatGPT about complex issues, it's become the problem of translating from natural language to a structured language such as SQL. And this is a task that GPT is very good at, right? So GPT can very quickly and effectively translate your wish to a SQL query. And when the data is simple, it's possible also for us. So thank you very much for listening and staying this far into the conference. You can feel free to reach me out at all these platforms. Thank you.
Thank you, very interesting. We are doing today INCD strategic cooperation with Google, and you touched actually 2 major issues that we are attacking. One is automation, how to do automatic investigation, and the second, how to do more specific language model for cyber. So it's very interesting. I got a quick question for you. All this stuff, won't this help also the attackers?
Well, yeah. So basically, attacking a network and infiltrate a network is also a data problem, right? So an attacker needs to scan all the available assets and data and look and basically, again, find a needle in a haystack, right? And the needle here is the vulnerability, while the defender needs to, the needle in the defender's perspective is the attacker's activities, right? So it's really parallel here, and at a certain level, such concepts can also aid attackers. So thank you again.